start, I would like to invite my business partner, co-CEO and co-founder of Exactpro, Alexey Zverev, who will share his views on deep testing. Thank you.
Hello, everybody. My name is Alexey Zverev. I'm a co-founder and co-CEO of Exactpro Systems. As Joseph mentioned, we are a company which is focused on testing of complex financial infrastructures, such as stock exchanges. And today I would like to discuss something that we call a deep testing. So what is a deep testing? Usually the definition of testing is running the software in order to find defects in it. But we define deep testing is a process of investigation of the behavior of the complex systems in different circumstances that might happen to production, and making sure that this behavior is understood and accepted by all system stakeholders. So deep testing is mainly what we do against the complex system. So what's a complex system? So we define a complex system is something which produces and receives substantial variety of different types of inputs and outputs. It demonstrates nonlinear behavior. For example, if you change slightly the input, you may dramatically change the output of the system. It consists of large number of heterogeneous components. It is run by many and executed by many parallel processes, and it provides usually it provides an infrastructure for big variety of automated partners. For example, if you are talking about stock exchange, in current world, the majority of trading is done by trading algorithms. So deep testing is targeting such systems. Let's discuss what is not a deep testing. We call this a commodity testing. You can see on the slide the approach that is widely adopted by many organizations. When you start with analyzing requirements, write test cases in some quality test management software, making sure that all requirements are presented in these test cases, execute these test cases, provide report to management with pass-fail ratio, and then after that automating the test cases. Now this is how many organizations approach to the testing of the systems, but what we would like to mention, but we would like to emphasize that deep testing is not really like this. Deep testing is a different kind of approach, and you will see it further during my presentations. I will refer to this commodity testing to compare our principles with what is happening here. So a few words on why do we need a deep testing. In modern world, if an organization employing and relying if your business or operation relies on some complex system, the malfunction of this system might actually be devastating for your business. For example, software glitches in exchanges are highly visible, and it affects the whole market or reputation of the country that's running the exchange. But even if you are not an exchange, even if you are a smaller business, if you are trying to maintain insufficiently tested complex system, the maintenance costs may be so high, so it can just damage your business and destroy it by just your inability to make sure that system works. So there are many examples of such events that everybody knows about. There were cancelled IPOs, there were plane crashes, etc., due to malfunction complex systems. So these are the principles of the deep testings as we see them. So this is not in an order, it's a random. All of these are equally important. So let's discuss it one by one. First of all, the first principle is exploration and experimentation. When you're testing complex system, you cannot know upfront what will happen, and you cannot prepare your test cases upfront. In order to test such system, you need to come up with ideas of what you are going to see, what you are going to test, and how you are going to test, and start testing. And then while you are testing the system, you will explore what's happening, and you adjust your test library, and this is a continuous process. The second principle is challenging assumptions. When you are dealing with complex systems, they usually demonstrate nonlinear behavior. When you change slightly input parameters, the output may change dramatically, and therefore any assumptions about the system behavior must be tested. If somebody tells you, for example, if developers tells you that, okay, this model should behave this way, you should not test it, then it's an assumption, and you should not trust it, because as we see many times, this might not be true at all. And or if business tells you that any specific conditions cannot be reproduced in production, this also might not be true, because in the modern world of complex systems, where a system is targeted by other algorithms that might misbehave, anything can happen in production, and your system must be ready to support it. The third principle is development mindset. It's again reiterating, you cannot come up with test library up front. You should grow it like a tree. You should start with some ideas and constantly improve your test library, adding test cases and modifying them. And basically, this is never-ending process. The equality of complexity. When you perform deep testing of specific system, if it's a complex system, then you will need a complex test library. It's impossible to use simple library to test complex system. And if, for example, your manager said that you will have, I don't know, 10 developers, and you will need only 2 software testers to test it, then it's not a deep testing, because the 2 testers cannot reproduce the same complexity that can be created by 10 developers. So this is our principle. You need to invest a significant amount of resources in order to match the complexity of the test library and the system under the test. Avoidance of simplification. For example, if you are testing some complex system and you try to focus on unit testing or isolate some of the modules of the system, then you are simplifying. You're making your life simpler, but by doing this, you're reducing the coverage dramatically. And therefore, if you are not testing system end-to-end, you're missing a lot of complexity, and you're testing something else, not the system that is going to be in production. And the principle is not to simplify your life by employing unit testing or isolated testing or something else. Mental model. The software testing, deep testing, is a collective learning. So in order to be successful in it, you have to build shared mental model. So rather than writing the test cases in quality center in many test cases with many steps, you need to focus on a lot of discussions of the system behavior of the testing, of what testing is done, what system looks like, and you should share this knowledge not only within the testing team, but between the all stakeholders such as developers, business, management, etc. And you should build adequate mental model for your system, which others may call test library. Next principle is instrumentation. You need tools to perform deep testing, but that's not how it usually looks like when in commodity testing, when you write some manual test cases and then use test automation tools just to make sure that these particular test cases can be running automatically without human intervention. You actually need test tools that gives you ability to test deeply, that provides more output that you can ever manage to provide when you are testing something manually. So in order to perform deep testing, it only can be done by the test tools in automated fashion, and it's enhancement of the tester capability rather than replacing it with robots. The preference of variety. Sometimes when we test, or many times when we test complex system, we might use different ways of interacting with the system or different approach to testing. And in some organization, it might be seen as a duplication of effort or inefficiency. But we believe that if we increase the variety of testing tools or testing input, we actually perform a good job of deep testing of the system. So the variety is essential because usually complex systems are targeted by a variety of stakeholders in production, and you should make sure that it is tested by a variety of test tools. The large number of tests expectation. Usually complex systems obtain quite substantial number of degrees of freedom, and that means that if you try to use Cartesian product, then you will automatically come up with a high number of test cases that you need to cover. That means that if you have a complex system and someone tells you that, okay, it can be covered by, I don't know, 300 test cases, then you should not believe it. Usually, if you have complex system, then you have to have number of large test cases, and it's a must. Observations priority. When you are testing, when you're performing deep testing, you need to focus on observations. Observations in our situation is a defects and question that is raised by the testing team when you perform the testing. Basically, if you do some testing, you must make sure that all your observations are reported and adequately, and you make sure that these observations are communicated to all stakeholders, and you make sure that these stakeholders, such as development team or, for example, management, understands your observations and acts upon it. So you must fight with mindset saying, oh no, this is not a bug, or this is invalid defect, or for example, it is not reproduced on my computer, something like that. You must make sure that anything that you observe during the testing is analyzed by developer, and that specific action is done against it. And the last one, the test data orientation. So basically, testing of complex system generates a large amount of test data, and without specific tools to analyze this data, you cannot actually manage it. So basically, when you do the testing of the complex system, you must collect, parse, and analyze the test data, and afterwards, this test data can be used as the strong and independent evidence of the testing quality and the system is ready for for production. So these 12 principles define our approach, our paradigm that we are trying to adopt in our company, and that we try to call deep testing. So that's it for my presentation. If you have any questions, feel free to ask either now or you can find me later.
Please raise your hand and we will bring microphone if you want to ask the question.
Hello, I'm Lyubakova from Exactpro. Thank you for your presentation. I'm wondering, how do you usually work with clients if they simply love quality center?
Mm-hmm.
If they love and they're used to it and it's their methodology.
Mm-hmm.
So do you have successful experiences of promoting your ideas in this case?
Well, we have different experience here. Usually if clients love quality center, that means that they are quite fond of the commodity testing, and we try to work with these clients to explain them our position and try to make sure that even we adopt some processes of the client's commodity testing approach. We follow these principles and explain them to the clients. It is usually a painful process, but it's a necessity.
I'm Pavel. Thank you for presentation. It was very interesting. The question is how to deal with deadlines which may be set by client if we do such deep testing, which result is not obvious. How can we may miss deadlines?
Yeah, usually it looks like that. Client have some deadlines in mind, but when we start doing this deep testing, we encounter a lot of defects, which in a way makes the client to delay their deadlines and give us more time to perform more deep testing. So if clients is adequate in terms of that they should fix the defects that are encountered during this deep testing, then we usually have significant time to test system thoroughly.
Okay, thank you.
Hello, thanks for presentation. I'm presenting Borusanke, Georgia. So you mentioned about number of developers and testers involved in deep testing.
Mm-hmm.
So if there are 10 developers and 2 testers, you're saying that it cannot be deep dive test.
Yes.
So what is the number of recommended resource, or in practice, how many people are involved in this deep dive testing for complex systems?
Well, it depends, but we recommend to have same number, 1 tester, 1 developer.
Thank you.
Okay, as I see, we don't have any more questions, so we would like to thank you, Alexey, for a very good and interesting presentation.